Okay, so lesson 4 involves solving equations that have variables on both sides. And when you have this, you're going to follow a few simple rules. Step 1, clean up each side of the equal sign. And that means, do you need to distribute? If so, do it. Do you need to combine like terms? If so, do it. Now remember, that's do it all on the left side, do it all on the right side, get them nice and clean. Once each side is down to one variable term and one constant term, then you're going to move the variable term from the left side of the equal side to the right side by adding or subtracting the entire term. Now you're down to a two-step equation. That means move the constant term to the right side by adding or subtracting, and then you're going to divide or multiply to get rid of the coefficient. Oops, there's supposed to be an N right there. Then, oops, well, pretend that says then. Okay, let's go to the next slide because that one was a fail. All right, so if you look at this one, you know I like to take my left side, put it in a box. Take my right side, put it in a box. Question, I'm only looking at the left-hand side. Do I need to distribute? Nope. Do I need to combine like terms? Nope. So now I'm only looking at the right side. Do I need to distribute? Nope. Do I need to combine like terms? Nope. That means both sides of the equation are as clean as they can get. So now I'm going to start from the right-hand side. I'm going to take the variable term, which is the 5x. It's the one with the variable, and I'm going to move it over to the left-hand side. I'm going to do this the same way I move any term from the left side of the equal sign to the right side of the equal sign. I'm going to add or subtract. In this case, because it's a positive 5x, I'm going to subtract 5x. Now I got to be careful. When I do that on the left-hand side, I've got to make sure I line it up with the variable term. Check over here, positive 5x, negative 5x cancel. Over here, I'm looking up and down at 7x minus 5x. And when I take 7x minus 5x, I get 2x. I haven't touched the minus, haven't touched the 2. There's an equal sign. Those are gone, so it equals 8. Voila! You now have a two-step equation. So over here on the left-hand side, I'm going to take that minus 2 and I'm going to add 2. I'm going to also add it to the right-hand side to keep it nice and balanced. The negative 2 and the positive 2 cancel. On the left side, I have 2x. Bring down the equal sign. 8 plus 2 is 10. Down to multiplication, or I'm down to a multiplication of a variable and a coefficient. So I'm going to divide both sides by the coefficient. The 2 over 2 cancels. I have x equals 5. Next one, I'm looking at the same thing. Left side, 9y plus 2. Let me ask myself, do I need to distribute? Nope. Do I need to combine like terms? Nope. So that side's clean. Right-hand side, do I need to distribute? Nope. Do I need to combine like terms? Nope. So that side's clean. So now I'm going to go on the right-hand side and look at the term with the variable. It's 6y. I'm going to move the 6y over to the left-hand side. To move a term, you add or subtract. So I'm going to subtract 6y. When I do that on the left-hand side, I'm going to put it under the 9y because it's a variable term and it matches. 6y minus 6y cancels. Then I'm looking at 9y minus 6y. 9 minus 6 is 3. Those were my y terms. I still have plus 2 equals, and on this side I have a negative 10 left. Down to that two-step equation. On the left-hand side, I've got the plus sign. I need to get rid of a plus 2 by subtracting 2 on both sides. The 2 and the negative 2 cancel. So I have 3y is equal to negative 12. Got my multiplication of a variable and a coefficient. I'm going to divide by the coefficient, which in this case is 3. The 3's cancel. Y is equal to negative 4. So the only thing new is moving that variable term over to the left-hand side. So let's try one more. Whoopsie doodles, you know what I like. When I see that y, I'm going to put a 1 in front of it. Is that left-hand side as clean as it can get? Do I need to distribute? Combine like terms? Nope, nope. Clean. Right-hand side, clean as it can get? Distribute? Combine like terms? Nope, nope. Clean. So I'm going to take the variable term from the left and move it over to the right. I do that by subtracting 11y. Okay, when I do this, I'm looking at 1y minus 11y. And 1 minus 11 is negative 10y. I still have minus 48. I have my equal sign. 11y and negative 11y cancel. So it equals negative 28. Down to a two-step equation. Over here on the left, I've got a minus sign. So I'm going to move the 48 by adding a positive 48. Negative 48, positive 48 cancel. I have negative 10y equals negative 28 plus 48 is 20. Down to that multiplication, so I'm going to divide by negative 10. The 10's cancel, the negatives cancel. I have y is equal to negative 2. Okay, now we got a little hitch in our get-along here. On the left-hand side, is it nice and clean? Yes. On the right-hand side, is it nice and clean? Yes. But I'm not going to follow the rule that I did on the other ones. Over here, remember we said we're always going to move stuff from the side that has the minus. There's my minus right there. It's on the left-hand side. So I'm going to move the term that I need to move. Now, most of the time we end up moving the constant. That's the number that doesn't have a variable. But in this case, if you look over here, this is a variable term. That's a constant term. Whoops, we've been calling it a number term, haven't we? And that's a variable term. I need to move the term that matches what I have on the other side. So that means I need to move my variable term. I'm going to take this negative 4w and move it over. I'm going to do that by adding 4w to both sides. When I do that, the negative 4w, the positive 4w cancels. I have 16 equals negative 6w plus 4w is negative 2w. Down to that multiplication, so I'm going to divide by the coefficient. The coefficient is negative 2. The 2's cancel, the negatives cancel. 16 divided by negative 2 is negative 8, and that's equal to w. I just want to show you what would have happened if I started with this and I moved the 16. It can be done. If I subtract 16, what I end up with, though, is negative 4w equals negative 6w minus 16. And then I would have had to move the negative 6w, and I get 2w equals negative 16, blah, blah, blah. The other thing that you could do, if you want to stick to what we've been doing, we've been moving this 6w, we've been moving the variable over to the right-hand side, left-hand side. So I have 14 plus 2w, you have to put the 0 there, and then you're down to a two-step equation, and you can solve it the same way. All three of those work. This is the preferred method. Your call. Okay, so this one, you're going like, Jackie, we're beating a dead horse here. We've got this on the right-hand side and the left-hand side. I do not have to distribute. I do not have to combine like terms. So I'm going back to moving this 5x over there. I'm going to do that by subtracting 5x. So what do I have left? Oh, those cancel and those cancel. I have 5 equals negative 12. So what you should notice here, there is no variable. The variable has disappeared. If there is no variable, I have two options. I could have something left that is true, or I could have something left that is false. What am I looking at here? Is 5 equal to negative 12? No, this is false. So if I've got a false one, What that means is there is no solution. So 5 equals negative 12 does not happen, so there is no solution. Okay, on this next one, a little bit different. Left-hand side, 6b minus 10. Good, good, good. Right-hand side, bad, bad, bad. On this side, I have to distribute. So I'm going to rewrite 6b minus 10. Over here, I'm going to do my little rainbows. 2 times 3b is 6b. 2 times negative 5 is negative 10. Now I'm going to move. I'm going to move this 6b over to that side. I'm going to subtract 6b on both sides. Cancel, cancel. What I end up with is negative 10 equals negative 10. So I'm back to where I just was. There is no variable. Variable has disappeared. It's canceled out. And what I have left is true. What that means is there are infinitely many solutions. Okay? No matter what I put in for b, it's going to cancel out, and I'm going to end up with negative 10 equals negative 10. So some people say this answer is all real numbers. That is true. That is true. I was thinking of something else. I totally lied to you. So this answer, if it's true, tells you that the solution is all real numbers. Remember, that's the symbol for all real numbers. In Lon Kappa, you'd actually probably have to write all real numbers. Okay, sorry about that little mess up there, but we're good. Oh, goodness. Look at this one. Left-hand side, no distributive property, but I do have to clean up. I've got a variable, a number, and a variable. So I'm going to put my two variable terms together. 4x plus 6x is 10x, and I still have minus 2. On the right-hand side, there's nothing that I need to do. It's already nice and clean. From the right-hand side over here, I'm going to move that 5x. I'm going to subtract 5x. Cancels. 10x minus 5x is 5x. I still have minus 2 equals 8. Over here on the left-hand side, I need to move that minus 2. I'm going to do that by adding 2. Cancels. 5x is equal to 10. Down to your coefficient and your multiplication. Divide by 5. X is going to equal 2. So all this is clean it up, or distributive property, combining like terms, move that variable term from the right-hand side, and then you're down to a two-step equation. So if I look at this one, over here I have to distribute. Low rainbow, spitchcoom, pitchcoom. Negative 3 times 2m is negative 6m. Be careful. Negative 3 times negative 5 is positive 15. On the right-hand side, there's nothing that I can do. I'm going to leave equals 3m minus 3. So now I'm looking at this side over here on the right. I've got this variable term. I'm going to move it to the left by subtracting 3m. So what do I have left? Those cancel. Negative 6 minus 3 is negative 9m. I still have plus 15 equals negative 3. On the left-hand side, I need to move the plus 15. I'm going to do that by subtracting 15. Those cancel. Negative 9m is equal to negative 18. I've got my multiplication, so I'm going to divide by negative 9. Remember, check to make sure you brought the negative along. So m is equal to 2. All right, we're getting pretty messy here. Over here on this side, I've got to combine like terms. Variable, variable, number. So I'm going to put my two variable terms together. 7 minus 2 is 5. Those are my y terms. I still have minus 48. And over here on the right-hand side, I've got variable, number, variable. So I'm going to put my two variable terms together. 8 plus 2 is 10y, and I still have minus 28. Down to that need to move that variable term from the right-hand side. I'm going to move 10y over by subtracting 10y. Those cancel. So I have 5 minus 10y is negative 5y minus 48 is equal to negative 28. I'm going to move from the left-hand side that minus 48. I'm going to do that by adding 48. Those cancel. So I have negative 5y is equal to 20. Down to that multiplication, so I'm going to divide by negative 5, and I end up with y is equal to negative 4. Watch your negatives, don't lose them. One more slide, and it's a mess. Left-hand side, happy, happy, joy, joy, nothing to do there. Right-hand side, do you see the distributive property right here? So on the left, I've got 2x plus 4. On the right-hand side, 6 times 3x is 18x. 6 times negative 4 is negative 24. And I still have minus 4x. Right-hand side still needs to be cleaned up. I've got a variable term, a number term, a variable term. So I'm going to add my two variable terms together. Left-hand side still 2x plus 4 equals 18x minus 4x is 14x, and I still have minus 24. Need to move this 14x from the right-hand side to the left-hand side. Going to do that by subtracting 14x. Over here on the left, 2 minus 14 is negative 12x. I still have plus 4. Those cancel, so it equals negative 24. Down to that two-step equation, I'm going to get rid of a plus 4 by subtracting 4. Those cancel. Negative 12x equals negative 28. Final step after multiplication is division. I'm going to divide by negative 12. I ran out of room, so I'm going to get x is equal to, what does 28 over 12 do? Well, it reduces. They can both divide by 4, so it would be 7 over 3. And that is what you do if you've got variables on both sides of the equal sign.